14.7, apply double angle and half angle formulas. So you should have those formulas written down in your notes. You're probably going to want to refer to them. There weren't any examples in the notes video, right? Where did it stop?
I only wrote down the first example.
You told us not to write down examples in the description.
I just did it.
Okay, well then I'm going to do these. So if you already have them, then you don't have to write them down. But cosine of 165 degrees. So that is not an angle that is on our unit circle, right? We skip from 150 to 180, so that's not one that we have. So we would have to use a half angle formula for that. And so this would be the cosine of half of 330 degrees. Now for the sines of these, it depends on which quadrant that they are in. So this would be in quadrant, well, the original angle would be up here in quadrant 2. So it's going to be negative, okay, because just the cosine. So this one is going to be the negative formula. So the negative half angle formula for cosine is negative square root of 1 plus the cosine of 330 over 2. What is the cosine of 330?
Root 3 over 2.
Root 3 over 2, so 1 plus root 3 over 2, all over 2. So I'm going to get a common denominator on the top, and then when I'm dividing by 2, that's the same thing as multiplying by 1/2. So I would have negative square root of 2 plus root 3 over 2, and that would have been the top part. Divided by 2, I can take and multiply this whole thing by 1/2. So this would become the negative square root of 2 plus root 3 over 4. Then rules of radicals, I can split that top and bottom. So I would have the square root of 2 plus root 3 over the square root of 4. And that's something we know. So it would be negative square root of 2 plus root 3 over 2. And that would be your final answer. So much like we had answers that all kind of looked the same with the sum and difference formulas, a lot of these answers are going to look similar as well for these ones. If they give you an angle in radians, I would suggest you convert it to degrees to deal with it, just to make it easier. So something like the tangent of pi over 12. How would I convert pi over 12 to degrees? Yep, so pi over 12 times 180 over pi. And yep. So now we're dealing with the tangent of 15 degrees. But not an angle on our unit circle, so I need to use one of the half angle formulas to find it. So the tangent of half of 30 degrees.
You know where Peter's?
His study hall.
Study hall.
Study hall where?
Either
Your lab.
library,
Probably.
either lab. I don't know. He's wandering around.
Oh. My bad. Joey, he's in Christian leadership.
All right, so formula for tangent, the half angle of tangent. There are two options for it, but I would use, or I'm going to use, the one that is 1 minus the cosine of 30 over the sine of 30. What is the cosine of 30?
I got it.
Same thing. Square root. Three.
Root two.
3 over 2.
Root 3 over 2. And what's the sine of 30? 1/2. So on the top, I would get a common denominator. So that's going to be 2 minus root 3 over 2, but it's divided by 1/2, so I would keep change flip. Multiply by 2. 2's cancel. And I'm left with 2 minus the square root of 3.
So how does the 1 become 2?
Huh?
How does the 1 become 2? Like on the top.
2 over 2.
Okay. Yeah.
All right, actually getting into some of the examples out of the book here now, or like some of the homework problems. Number 4, we have the tangent of 112.5 degrees. And it wants me to find the exact value of the expression, so just what I've done in the last couple. So what would the angle be that this is half of? Yep, 225. So this is going to be the tangent of 225. Since I used this formula in the last one, I'll do the reversed one where it's flipped in this one. So that would be the sine of 225 over 1, I think it's plus, right? Yeah, 1 plus cosine of 225. So what is the sine of 225?
Negative root 2 over 2.
Yep, negative root 2 over 2.
Same thing for sine. Pretty sure. Yeah.
Cosine.
Means
So 1 minus
Yeah.
root 2 over 2. So the sign on the bottom was positive, but since that value is negative, I'm just replacing it. So I'm going to do common denominator on the bottom. So I'm negative root 2 over 2 over 2 minus root 2 over 2. Keep change flip. So I have negative root 2 over 2 times 2 over 2 minus root 2. These 2's cancel. You cannot, because I know somebody's going to ask, you cannot cancel the negative root 2 on the top and this one over here because this one's being subtracted from something else. So I would have negative root 2 over 2 minus root 2. Do you think that I'm done?
No.
Why?
Good. Radical on the bottom.
So how might I get rid of the radical on the bottom?
multiply it by negative square root of 2 over square root of
2 plus square root of 2.
Yeah, 2 plus root 2 over 2 plus root 2. If I just multiply by root 2, this one's going to go away and this one's going to end up with a radical on it. So, multiply by the conjugate, so 2 plus root 2, top and bottom. So I'm going to get negative 2 root 2 minus root 2 times root 2 is just going to be 2 over, on the bottom, that's a difference of squares, so 4 minus 2 which is going to be, I'm just going to mark this out, 2. Am I done now?
No, because can't you cancel?
I can, okay? Now, again, I'm going to reiterate something that I said a while back that I just don't want you to forget, because this stuff is being, subtracted in this case on the top. I have to take a 2 out of the top to be able to cancel it. I can't just be like, oh, I'm going to cancel this one and this one. Like, it doesn't work that way. Okay, it has to be canceled out of everything. So I would have to take out a 2, which would leave me with negative root 2 plus 1 over 2. Now I can cancel, and I would be left with negative root 2 plus 1. This is probably my least favorite trig section, and it's probably going to be yours as well, just a guess.
I don't think anything could beat the formulas we had to do. That was
Yeah. They're a lot. But unfortunately, you have to know them. So they are useful, and you have to know them next year, so might as well learn them now. Um, six. Cosine of negative 75 degrees. If you have a negative angle, we have to find a positive angle that's equivalent to it, okay? But not yet, okay? I want to figure out 75 is half of what angle? Just disregard the negative for the moment. Did you say 50 or 150? Oh, yes. I thought you said 50, and I was like, no. Okay, so this is, I'm going to imagine, is half of 150. Did I forget to put the half in that one? I did. This was supposed to be half of 225 up there. Okay, so half of 150. Or I guess it should be negative 150 because this was negative. Now, we can't do it for negative 150, so I need to treat this as a positive. How would I find a positive angle that's equivalent to this? Add 360. So we're going to do this as the cosine of half of 210. Okay, so we found its coterminal angle. Now, sine and cosine are the ones where I have to figure out if it's positive or negative based on where my original was. So is the cosine of negative 75 positive or negative? So basically in quadrant 4 is cosine positive or negative? Positive, okay? Because it's negative 75 would be down here, okay? Cosine would be positive, so my function is going to be positive. So I'm going to put the positive there so that I know. I'm not going to bring it down after that. The only time I'm going to bring it down is when it's a negative, but I want to see at least in the first step that you intentionally checked if it was positive or negative, and that way I don't think you just weren't paying attention to that, okay? But after that, you don't need to bring down the positive with it. So then the square root of my formula, 1 plus the cosine of 210 over 2. So what is the cosine of 210? negative root 3 over 2 over 2. So then common denominator on the top, 2 minus root 3 over 2. I'm going to go ahead and deal with this times 1/2, and that's all under the square root. So I'm going to go ahead and, well, I'll do it. 2 minus root 3 over 4, which is square root of 2 minus root 3 over 2.
I don't understand. For when you go from the 1 plus, how you get the 2 minus root 3 over 2.
I'm just rewriting the 1 as 2 over 2. And then adding the top, or in this case subtracting, because I have common denominator now.
Oh, okay.
I'm just trying to avoid having to write the really long thing a million times. And I mean, in pretty much every scenario, because we're dealing with sine and cosine, it's always going to be something over 2. So you could always just start out by writing the 1 as 2 over 2 if you wanted to. Because even if it was 1/2, you would still need it to be 2 over 2.
How come on the last thing you just wrote, only the top isn't a
Because the square root of 4 is 2.
row? Okay.
Okay, rules of radicals say that I can split this. But I'm not writing every little thing out because it's a lot. Let's see. 8, sine of 5 pi over 12. So what do I need to do first? Yep, make it degrees. So I'm going to do 5 pi over 12 times 180 over pi. Pi's cancel. We said 180 over 12 earlier was 15, so
15 times 5.
it'd be what?
75.
Yep, 75 degrees. So the sine of 75 is half of what angle?
150.
Yep, half of 150. Now, where is the sine of 75, or not where is it, but is it positive or negative?
Positive.
Positive, so when I set this up, it's going to be positive square root of 1 minus the cosine of 150 over 2. What's cosine of 150? Negative root 3 over 2, so square root of, I'll do it this way this time, 2 over 2 minus, nope, plus. So notice formula was minus, but that value is negative root 3 over 2, so it's going to become plus root 3 over 2 over 2. So then I've got the square root of 2 plus root 3 over 2 times 1/2, which is going to end up becoming the square root of 2 plus root 3 over 2, just to save having to write it out all the time. If you want to write it out like I've been doing, that's fine, but if you want to shorten it down and do it like this, that's also fine. Okay, these next ones, and this is going to be probably when we get to this point all we do for today, and we'll save double angles for Monday, just because We might have a couple more half angles on Monday, but primarily saving double angles for Monday. These next ones say find the exact values of the sine of a over 2, cosine of a over 2, and tangent of a over 2. And they give us something like this. It's number 12. Cosine of a is equal to 4 over 5. 0 is less than a is less than pi over 2. So what quadrant is this occurring in? First one. Okay, so just like if we're just disregarding the instructions for the moment, okay, we're going to set this up just like we did back in the early part of chapter 14. I think it was chapter 14. I don't know. All my classes run together. So we're going to draw this triangle up here in quadrant 1. Cosine is adjacent over hypotenuse, so this side is 4, this side is 5. What do we know the other side is? 3. Knew we'd get it. So now I need to write out, okay, because, and I'm going to tell you why, we're trying to find sine of a over 2, cosine of a over 2, and tangent of a over 2. So I need to write out sine, cosine, and tangent of a. Okay, I don't need to worry about secant, cosecant, and cotangent because I'm not going to be using those. So sine of a would be what? 3 over 5. Cosine of a was given to us. You can write it again if you want or not. It doesn't matter. Tangent of a is
3 over 4.
3 over 4. All right, so now the instructions want us to find first the sine of a over 2. Now, these ones, they don't give us an angle, but they tell us that a is somewhere between 0 and pi over 2. So when we set this up, we're using the formula, okay, just from your notes, and then we're going to be replacing cosine of a or sine of a or tangent of a, depending on the problem, with what we found up here. So sine of a over 2 formula is the square root of 1 minus the cosine of a over 2. Cosine of a, I'm not using my unit circle now, but cosine of a is 4 over 5. So this is going to be the square root of, since I know I'm going to have a denominator of 5 over here, I'm going to rewrite 1 as 5 over 5 minus 4 over 5 all over 2. Are we tracking so far? Okay. So then this is going to be the square root of 1/5. It's being divided by 2, so times 1/2. So this is going to be the square root of 1 over 10. I can split this radical up into square root of 1 over the square root of 10. So the top is going to be 1, bottom is square root of 10, meaning then when I rationalize it, I get square root of 10 over 10. And if you didn't need to write out all those steps, you don't have to. I just did it so we would see it on this one. So that is the sine of a over 2. So you're going to notice like the math for these ones is a little easier because you're not dealing with so many like square roots within the problem. At least most of the time. Cosine of a over 2 is the next one. So that formula is the square root of 1 plus cosine of a over 2. So this is going to be the square root of, again, I'm going to use 5 over 5 for 1 just so I can save a step, plus 4 over 5 all over 2. So then that is the square root of 9 over 5 times 1/2. Square root 9 over square root 10. Square root of 9 is 3. And I'm going to go ahead and rationalize it here. So this is going to be 3 root 10 over 10. And the last one they need from us is tangent of a over 2. Which tangent formula do you want to use? Basically, do you want the one with sign on the bottom or the top? What? Top? Alright, so sine of A over 1 plus cosine of A, I think. Yes. Huh?
Wait, my note says negative
Sine over.
1 plus cosine of A. Alright, so sine of A was 3 over 5. So on top I've got 3 over 5. On the bottom, cosine of A was 4 over 5. So again, to get a common denominator, I'm going to write 1 as 5 over 5 plus 4 over 5. So that's 3 over 5 over 9 over 5. Keep, change, flip. 3 over 5 times 5 over 9. 5's cancel. 3 and 9 reduce to 1/3. Do y'all feel like you need to see another one of these ones, or are we okay? We're good? Alright. Then the problems I'm going to give you to work on for today. And then, like I said, we'll do double angle formulas on Monday. So 3, 5, 7, and 15. And so those ones will be like the ones we just did. So where we'll start on Monday is a problem just like this, except for we're using the double angle formulas, and then we'll move into some double angle problems as well. But the setup of it will be the same way.